Hey everyone, today we're going to break down a concept that honestly powers pretty much everything around you, from your car to your phone, designed for reliability. We're going to get into the absolute essentials you need to understand how engineers actually make things that last.
All right, so here's our game plan. We'll kick things off with why this stuff even matters. Then we'll get into the nitty-gritty of what reliability actually is. After that, we'll look at how it's designed and tested, and wrap it all up with some real-world examples.
So before we jump into all the engineering jargon, let's just ask a really basic question. Why should anyone care about reliability in the first place?
Oh man, we've all been there, right? You're rushing to check out, you've got the thing in your cart, and the whole site just dies. That feeling of frustration, that's the feeling of unreliability. That e-commerce server buckling under pressure is a textbook reliability problem. It failed to do its job right when you needed it the most.
And this is exactly where it hits the bottom line. See, reliability isn't just some extra cost for engineers to worry about. It's a direct investment in a company's success. When you get it right, everything gets better. You have happier customers, your brand looks good, you spend less on repairs and warranties, and, crucially, you ensure things are safe.
Okay, so we know why it's a big deal. Now let's get super clear about what it is. Seriously, getting these core concepts down is the key to understanding everything else we're going to talk about.
Okay, this is the official textbook definition. And trust me, every single word in here is critical. It's not just about working. It's the probability it will work for a specific amount of time under specific conditions. If you take away any one of those pieces, the whole definition just falls apart.
Now this chart, this clears up one of the biggest mix-ups out there. People use quality and reliability interchangeably, but they are not the same thing. Here's the best way to think about it. Quality is a snapshot. Does the product work perfectly right out of the box? Reliability, on the other hand, is the whole movie. Does it keep working over its entire lifetime? So, how do we measure this stuff? Well, we've got a few key metrics. First up is MTFF, or mean time to failure. This is for all the things you don't repair. Think a light bulb or a chip inside your computer. It's basically the average lifespan before it's gone for good.
Then you have its cousin, MTBF, or mean time between failures. This is for things you can and do repair, like that web server we talked about, or your car. It's not measuring the total lifespan, but the average time it runs perfectly between breakdowns.
And the last piece of our measurement puzzle is the failure rate. You'll often see it shown as the Greek letter lambda. All this tells you is how often something is expected to fail over a certain period. Simple as that. These three metrics are the language engineers use to talk about and improve reliability.
All right, so we've got our definitions, we've got our metrics, but how do you actually build this stuff into a product from the get-go? Let's take a look at the engineer's toolkit.
Engineers have this whole bag of tricks they use to prevent failures before they can even happen. For example, redundancy is just what it sounds like. Having backup systems. Think about airplanes having multiple engines. Derating is another cool one. It means you deliberately run a component at, say, 70% of its maximum power, just to reduce stress and make it last way longer. It's all about being proactive and designing failure out of the system from day one.
A brilliant design on a computer screen is one thing, but it's just a theory until you prove it. And that's where testing comes in. You have to make sure the reliability you designed on paper actually holds up in the messy real world.
So, you can't just wait around for 10 years to see if your product with a 10-year lifespan actually makes it, right? So what do engineers do? They speed up time. They use methods like ALT, accelerated life testing, where they crank up the heat or vibration to simulate years of use in just a few days. Then there's HALT, highly accelerated life testing. That's where they push a product until it breaks, just to find its absolute weakest point. It's brutal, but it's how you find problems fast.
Okay, let's put all this together now. Let's see how these principles, the definitions, the design tricks, the crazy testing, all come together to solve actual problems you might have seen.
So let's take your car's ECU. That's basically its electronic brain. It has to live in a really harsh environment with constant vibrations and temperature swings. So engineers run an analysis called an FMEA. It's a systematic way to predict what could go wrong. They identified heat as a huge risk. So what did they do? They designed in solutions, protective coatings, better heat sinks, backup power. The goal? An MTBF of 100,000 hours. That is over 11 years of running nonstop without a failure.
All right, for our second case, I'm sure this one sounds familiar. A really popular smartphone was getting tons of complaints about the battery overheating while it was charging. So they dug in, and the investigation pointed to one specific little component in the charging circuit that just couldn't handle the stress.
And the fix was a classic reliability move. The team improved how the phone managed heat, and they derated that failing component. Remember, that just means that they decided to run it less hard. The result? A whopping 45% improvement in the battery's mean time between failures. A simple design change made a massive difference in how dependable and safe the phone was.
Look, if you only remember one thing from all of this, please let it be this quote. It's so important. You cannot wait until the end of the production line and then try to inspect or test reliability into your product. It just doesn't work that way. It has to be baked in from the very first sketch, from day one.
So, I'll leave you with this to think about. What's the most dependable thing you own? You know, that old tool, or that appliance, or maybe a car that just refuses to quit? Take a second and think about it. What design choices do you think the engineers made that have earned your trust for all these years?